All right, you guys, we're going to wrap up the unit today with 9.4, analyzing lines of fit, okay? Our two key learning targets up here, 9F, analyze key features of a scatter plot based on given information, and 9G, compute and interpret the correlation coefficient for linear data. Okay, so as we jump down here into the actual notes part, correlation coefficient is the number we're going to be focusing on today, and we always relate the correlation coefficient to the variable r. And R is a number between -1 and +1 that indicates the direction and the strength of the linear relationship. Direction meaning positive and negative, strength meaning how closely the numbers are related. So if R is close to 1, +1, it has a strong positive correlation. Okay, meaning they're all going up together and the numbers or the points are all really close to the line, close together. If R is close to -1, it has a strong negative correlation. And that means the same thing, only opposite direction. So negative all going down together and they're closely related to the line. Then if R is close to 0, it has what we call a weak correlation, meaning that none of the points are really um, related to each other. They don't really follow any type of pattern. So the relationship here, you can see R 0.984, that's really close to +1. They're all going up together and they all kind of stay close to that line of best fit. So this would be a strong positive correlation. Okay. This next one is negative 0.284. You can see as you put the line in, none of the dots are really following anything that's happening there. So we would call this a weak correlation because it's both close to 0 and the dots are all scattered. And then we have over here negative 0.995. And you can see, again, they're all going down together. They're all really close to our line of best fit. So we would call this a strong negative correlation. Just giving an example of what they all look like, okay? Pause the video for a second and see if you can give me a relationship for numbers 1 and 2. Okay? Hopefully you got that this is a weak correlation and this one would be a negative correlation. We wouldn't necessarily say this one was strong because 0.6 isn't really that close to 1, but we do know that the numbers are going to be fairly good as far as going in the negative direction. Okay? All right, so next one, interpolation and extrapolation. So interpolation is going to be using a model to estimate a value within a range of known values. So if they give us a range of numbers, we can kind of estimate where we think another number might fall based on what we already know. Extrapolation is using a model to make a prediction of a value outside the range of values that we know. So again, they're going to give us a certain set of numbers, and interpolation would be inside that value set. Extrapolation would be outside, okay? Exterior, interior. So to kind of help us out with this part, we're going to create a scatter plot and line of best fit on Desmos today. So the graphic shows regional air travel data recorded by a domestic airline company. How can you use the data to estimate the number of air miles people flew in 2003? So this is our key here, 2003. And that's what we're going to be solving for because it's inside here, but it doesn't really show us 2003. So that would be interpolation. Okay. And then we're going to be putting these into Desmos. So a couple of things to think about here. First of all, the year, that would be time. So this is going to be X. So this chart's kind of backwards. And then the air traveled miles would be Y. Okay. The other thing here is that it starts at 1975, and we can't put 1975 as a number of years into our scatter plot as a graph. So this is actually going to be like 0, like we're starting at 1975 and moving up from there. So then this would be 5, 10, 15, 20, 25, and so forth, okay? So what we're going to do is go to desmos.com, okay, and see if we can get this to get this thing going, to graph, okay? So here's Desmos. We're going to do the graphing calculator. All right. We're going to click on this little plus in the corner, and we're going to add a table, okay? And our table of values are going to follow this airplane model that we just had here, okay? So in my x's, I'm going to put those bottom numbers starting at 0, like we talked about, and go from there, okay? So 0, and then 5, 10, 15, 20, 25, 30, and 35, and 40. Okay, and then I'm going to go up here on my Y, and I'm going to enter the numbers that it has for the miles for each one of those. So, sorry, let me get my paper here so I can see a little better. 1298, 1529, 1720, 2118, 2387, 2697, 2973, 2945, and then 3055. Okay, then this is the part you probably haven't done yet. Because our numbers are so big in our chart, our graph isn't showing anything because this graph doesn't go far enough to reach these numbers. So we have to adjust our axis, okay? So this wrench up here in the right corner is going to let us do that. My x-axis, you can see our numbers go from 0 to 40. So I'm going to say from negative 10, and I'm going to change this to be 50 so that it shows me all the way across. And then the y is showing us from like negative 7 to positive 7. I'm just going to adjust this. Our y started at 1,000. So I'm just going to start this at 1,200. Oops. And then I'm going to end it all the way down at 3,100. And then I can see all my stuff here. Okay, so now I can see my points. Okay, then to do the linear regression, you have to get an equation of line of best fit. So we have to put in a weird kind of equation for what we normally do. So I'm going to go down here to number 2, and I'm going to put in what you see here in this box. You guys, I'm just following the steps here. I'm going to put this equation in number 2 right here. So a couple of little buttons you probably haven't seen before again. This is going to be Y, and then when you do, let me see here. Okay, so on the Desmos screen here, sorry about that, we're going to type in the equation that you see here, okay? And you have to type it in like this one up here. So this little button up here, we're going to have Y, and then you're just going to type 1. And then your like similar line, or that little like squiggly line, is up in the top left-hand corner of your keyboard, above the tab. And then you're going to type AX1 and then plus B. Okay, and then it's going to pop up this little box that you see, just like you see here. It's going to have all these numbers filled in for us, okay? So we're going to have our R squared value, we're going to leave blank. Our R value, that's our correlation coefficient, is 0.981. So here, we're going to put 0.981, okay? And then our A value, if you flip back over, our A value is 47.87. So 47.87. And our B value is going to give us 135.04. So 1345.04. And all of that is right there on your decimal. So you can see our lines are all going up together. They're pretty close to our line of best fit. So that's why our R number is really close to 1. So this would mean we'd have a strong positive correlation happening here, okay? So using these numbers, we're going to write an equation for our line that we just made, okay? So A is our slope, that's our M, right? B is our y-intercept, where it crosses the y-axis, and we're going to write y equals, and we have 47.87x plus 1345.04. Okay. So then it asks us up here at the very top to answer that question about when it was 2003, how many miles people probably drove. Well, again, we're using the years since 1975. So we got to take 2003 minus 1975, and we've got 28 for that. So it's been 28 years. So our years is our X value. So it's going to plug in right here. So 47.87 times 28 plus 1345.04. And if you type that in your calculator from left to right, you're going to get y equals 2685.4 miles. Okay? All right. So if the trend continues, what would be a reasonable estimate for the number of miles that people will fly in 2030? So this would be extrapolation because it's outside or the exterior of the values that we have there. So again, 2030 would be our year. We started in 1975. That means it would have been 55 years. So I'm going to use 55 for my X, and I'm going to plug it in again. Y equals 47.87 times 55 plus 1345.04. Type it in from left to right, multiply and add, and we get 3,977.89 miles. Okay? Okay, so then using the information in example 2, estimate the number of miles flown, people flew on the airline in 2012. So you guys do that one real quick. Pause and see what you get, and I'll show you my answer. Okay, so if you're doing this and you're coming back, 2012 minus 1975 would be 37 for my X. Again, we're going to type it in the exact same way. Times 37 plus 1345.04. And your answer should have been 3,116.23 miles. Okay? Okay, so last part here, example 3. Causation is what we're going to look at next. So causation describes a cause and effect relationship. Okay? A change in one variable can cause a change in the others. This should say 1 over here. Sorry about that. Correlation and causation together. A student found a positive correlation between the number of hours of sleep his classmates got before a test and their score on the test. Can he conclude that he will do well on the test if he goes to bed early? Well, so this is saying, this line over here is showing us that most of the time, the more hours of sleep you get, the better you're going to do on your test, right? But we know that that means people are refreshed and ready to go, but it doesn't necessarily mean that they've studied and that they know what the answers are going to be to the test, right? Sleep just helps you focus and kind of move forward. So this one would be not necessarily, right? Like just because you go to bed early doesn't mean you're going to do really, really well on your test. You also have to study. So other factors there that are helping us determine that number, okay? Another example, a member of the YMCA notices that the more minutes she is working out, the more calories she is burning. Can she conclude that the more minutes someone works out, it will result in more calories burned? Well, this would be yes, because we all know that the more you're moving, the more calories you're burning throughout the day. It doesn't. That's a direct correlation to each other. All right, and last one, a lifeguard notices that as the temperature outside rises, the number of people coming to the beach increases. Can she conclude that the change in temperature results in more people going to the beach? Um, well, I mean, again, same thing, right? Like you're noticing this, but it's not necessarily the only reason that people go to the beach. And it's not going to guarantee that that's going to happen. So she didn't conduct any type of experiment. She's just noticing that this is happening. So we would need to probably have more variables there. So this would be no, more variables needed to actually conduct an experiment. Okay. All right, there you go, guys. Good job.